invite the next author. Paper ID is 3519, Multilingual and Cross-Lingual or Audio Emotion Analysis using RNN. Mr.
Yes, sir.
Sudipta Bhattacharya. Are you there?
Yes, sir. Good afternoon, all of you. So today my presentation on the topic of multilingual and cross-lingual audio emotion analysis using RNN. So first of all, myself Sudipta Bhattacharya, and I'm from JIT University as a research scholar. So in introduction part, what I want to say that detecting emotion is very critical job, and we will detect feelings from the speech, and it is very important because it is very hot topic nowadays for according to the human computer interaction, and it has a potentially very wide application over here. In 2020, the speech recognition market has grown to $10.73 billion and projected up to 17% growth rate in 2026. And detecting emotion is one of the most critical and marketing strategy. So it could see the person feelings of their speech. So before starting going to this topic, I want to say that what I actually do in this my work, that in this work I have gone through some, want to do some experimental things on monolingual, multilingual and cross-lingual audio emotion. From there, I extract all the information from there. So this approach is that emotion detection mainly from the different audio, different techniques like different European language like English, Italian, French, German, different types of language, and extract from the monolingual. In case of monolingual, the basic part, I'll come to that part. So in that literature survey in German and French language, I have gone through some very important some literature for that. Zhao et al. And Demikran and East et al. And Perrier. This four paper is very important for the only German and French languages database. What they have done, their accuracy and they have working with the feature. The same thing we have also experimental onto that. But our model are outperform than this. Except that Zhao et al. They have some changes only on the speaker independent, and this is the we have expect from except this Zhao et al. We got our model make some best performance over there. The next is the in case of English language databases like Ravness database and Test database. We have worked onto that. So there is a 4 important paper for that. In that there is the Sagrekor, Jen et al., Zhang et al., and Papuga. They have working with a very good features and as well as some classifier also. But our performance is much more better than this in case of English language. And for the Italian language, these are 2 things: Latif and Haidar. They have also worked with these features of Latin code and EGMPS. And as they have used also the classifier of SVM, and they got the accuracy. But our approach is much more better than this 2 also for Italian language. So these are the database what we have actually used. Is a test database, EMODB. EMODB is a German database. Test database is for the Canadian English language, and this test database have the only 2 female actor is there. They're the age between one of is 26 and another is at 64, and 8 emotions is there. In that particular database, 2,800 utterance is there. Language is Canadian English, and emotions is angry, disgust, fear, happiness, etc. And the sample rate is 48 kilohertz. So similar for the EMODB is a German database, and it has consist of 5 male and 5 female, and the age range is 21 to 35, and it has also 7 emotion, and their utterance is 353. And for the French database, 16 male and 16 female, 7 emotion is there, 502 utterance is there. And for the Ravness database, it is also English language database. They have 12 male and 12 female from 21 to 33 age. Emotion is 8. Now 8 types of emotion is there, and utterance is 1440. And for EMO-BO, that is the Italian language, that Italian language emotional database, they have also 3 male and 3 female is there from 21 to 35 age, and emotion is 6. So now what is the methodology? According to the methodology from that audio sound, I have extracted MFCC features, and before that, I have also do some data augmentation policies. Like I have a very few data for in case of EMODB 535 and EMOVO 585, and so and 502 for the French database. So I need to augmentate that data and pitch that, shifting the pitch to the sound and stretching the sound, shifting the sound, and including some white noise onto that. And after that, I do some k-fold cross-validation augmented technique has been proposed. And then after that, I have used that RNN model, which is I have used over here LSTM. So this is the proposed LSTM model. This LSTM model has already, we have seen that in according to that LSTM model, in RNN model, they have the approach that three portion. One is a forget gate and input and output gate. So in this LSTM model, I have proposed this model. And overall, when I have used this from data preparation from raw sound to it is converted into the MFCC and it is converted into the proposed data. Then after that, after doing the data augmentation for the 4 data augmentation technique has been done. So if I go through only 504 is the data into 4, that means near about 2000 data have been created. Then what I have to do, I have already done in k-fold cross validation for that approach. Then after that, that data is part into test and train data. Then testing has been done and training also done and validation also be done. Then ultimately classification has been gone through like different emotional policies. So from this result, here I have given that monolingual approach. In monolingual approach, monolingual mean train with the English database and as well as traced with the English database, emotional database. And I have also done some model in CNN and LSTM, and in both case I have got accuracy according to 70.46 and 90.890. So similar for the EMODB, that is a German database. Test training has been done in German. Testing also has been done in German. So similar for Italian, similar for the French, and similar for the Canadian English. But the next one is in case of multilingual. I have already only done for multilingual in English. That is in multilingual for original. I am testing with an English and I am training with English and testing with all the database. All database means is combination of Italian, combination of German, combination of Canadian English, different everybody's. And doing the same approach and got the accuracy in case of multilingual database for the English training. 7259 is the accuracy. In case of normal CNN approach, in an augmented CNN approach, I have done 89.19. And similar for done in LSTM model, which is better than the CNN, which is 87.88 and 93.41. So similar, and in case of cross-lingual training with all and testing with only that particular language. Like first I have tested with all language and as well as in case of testing with the German language. Similar for the French, all language I have training, then French, then Italian, then Canadian. We have done this kind of approach for the cross-lingual database. So in this work, I have seen that different researchers incorporate various combination of emotional features, and researchers are still in the debate that which is the best features of the sound. So these are the part we have to do something more research onto that. And we have also increased the epoch and changing the optimizer, changing batch size. It may be reflected some the good sign of accuracy, but our LSTM model especially show the better result than CNN, and still some experiment that has been outperformed than the CNN. But in case of test database, showing the best result, and in case of multilingual cross-lingual database, LSTM model outperformed than CNN model. So this is our observation. So these are the reference. So thank you. Sir, if you have any question.
One query is there. Can you highlight the disadvantage in your system, if any?
Yes, sir. There is something. First of all, what we did right now, it is an European based on languages. Okay, so lots of different languages can be done. Second thing is that features can be, if the number of features is increased, it can be reduce some whenever we are using 100 and 150 epochs over there, and somehow in that case that could be removed, or that could be decreased, because the computation will be computation can be reduced from there. And so these are the disadvantage I have seen.
Okay,
And
okay.
another thing is that, sir, another more important thing is that we are talking about only one modality, like sound, audio. But as well as if we add the text part also, in different another modality, then it could be a better.
Okay. Test compatibility means, are you going to convert that particular language into
Yes, sir.
English, or generally uh, display whatever it is saying?
No, sir. Actually, text means that suppose I'm talking, this is the audio, and the similar thing is if it is in a written mode, that is in a text.
No,
So
no,
that
not
modality I
thing.
want to say.
As you have mentioned that it is multilingual. For example, let us say
Yes.
that I'm speaking in Hindi. आप कैसे हैं?
Hmm.
It is going to convert as it is in English, or it is going to
No,
convert
sir. I'm here. What actually did that? I'm talking about only emotion,
emotions. Yes.
only emotion. Okay.
Uh,
I'm not converting any the
Means
things
an
into that.
image, right?
Not. I'm only doing in the audio part.
Audio. Means whatever
Yes.
audio expression is there, based on that, it is performing the analysis, right?
Yes.
Okay, okay,
Okay.
okay.
Any other questions?
Nothing,
Okay.
nothing.
Thank you.
Thank you.